we go over the homework that was due, I'd like to go over the formula again that all this is based on. All right, so all of this is based on the percent increase / decrease formula. So this is worth writing down in your notes again. And I'm going to go through each number in each thing today and make sure you really understand it. So these are the percent increase decrease formula, which is A, sometimes you see it A of t like that, equals A sub 0, 1 plus minus r to the t. So anytime you see questions with percentages in it, this is what you want to think about, where they tell you you have an original amount and a percent. This is the formula. And let's run through what everything means again. I'll use my red pen. This is your amount over time. So your answer, basically. Okay? Now, A sub 0, that's always going to be the original or current amount, depending on the wording of the question. So it's what you're starting with. 1 is always in the equation. Now, if the equation is increasing, it means we're going to be adding on to 1. If the equation is decreasing, we're going to be subtracting. So that's why there's a plus minus, because we have two options. R is your rate. Okay, so what you're going to do is always convert the percent into a decimal. All right, and finally, T is time, which everybody always understands. All right, so this is the formula that we're using on the homework. Now, looking at the homework, a lot of you did understand it. Looks like some rounding issues and things like that, but overall, you guys understood it. I am going to go through every question just to make sure, and we're going to practice again today. So here was the homework assignment, and the very first question said, I'll see if I can get a little closer so you can see it better. The amount A in milligrams of a 10 milligram dose of a drug remaining in the body after T hours is given by this formula. So I'm going to underline it. So that's our formula. Find to the nearest tenth of an hour how long it takes for half of the drug to be in the body. So the formula is A equals 10, 0.8 to the T. Now let's read it again. Find to the nearest tenth, so 1 decimal point place, how long. Long is time, so that means we're going to try to be solving for T, for half of the drug to be in the body. Okay, how much drug did we start with? And again, the original amount is 10, right, because that number's always the original amount. Right here, they even said it was 10. So what would half of 10 be? And I hope you said 5. So we want to know when the answer here is going to be 5. All right, now we're trying to solve for something in the exponent. So there's an x in the exponent, and that means we're going to log it. But I can't log it yet, because what I want to do is get rid of the 10, move it over to the other side, so this guy's alone. So I'm going to divide both sides by 10. You always want to get rid of what's in front of the parenthesis. So 5 divided by 10, that's just 1/2. Right? I didn't use my calculator for that. That I can figure out. So that's going to be half, or 0.5, equals 0.8 to the T. Now I can log it. All right, so I'm going to log both sides. So I get log 1/2 equals log 0.8 to the T. Right? And where does my exponent want to fall? In front. So this becomes log 1/2 equals T log 0.8, and then divide over. Right, so what I'm going to do next is divide by log 0.8. So I'll write it here, what I'm going to write down. So I'm going to put in my calculator log 1/2 divided by log 0.8. So my calculator, log 0.5 divided by log 0.8, and I'm getting T equals 3 point, and then I'm going to double check it once to the nearest tenth, so 3.1. Which a lot of you had when I looked. That was great. Another way you could do it, remember there's always two options. You could have taken this, right? And then just log 0.8½ equals t, and you get the same answer. So depending which way you did it, they're both correct. Okay, number 2. Depreciation, the decline in value on a car, is determined by this formula. All right, V equals C 1 minus R to the T. Now guys, this is literally the percent increase decrease formula. They just changed the letters. And since it's depreciation or decline, that's why it's a minus. Where V is the value of the car, T is yours. C is the original cost. R is the rate. Okay. If the car's cost when new is $15,000. So again, that's the original cost. So that's going to go where the C is. So I'm going to put 15,000 there. Parenthesis 1 minus 30%. Now 30% is a decimal, it's 0.30. And the value of the car now, so that's the V, is 3,000. Find T. Okay, so now I'm going to do exactly what I did in the last question. I'm going to divide by 15,000 first. I'm going to divide by 15,000. Okay, so if you go to your calculator, you do 3,000 divided by 15,000. I'm getting 0.2. So this now comes up here. I get 0.2 equals, now 1 minus 0.30 is 0.70. So it's going to be 0.70 to the T. Now, 2 ways of doing it. One is the quick way, where we do log, the base is 0.70, 0.2 equals T. So that's the quick way of doing it. Hit the math button, scroll up, and we'll take in 0.70 and then put in 0.2. And I'm getting that. Now let me double check. I want nearest tenth of a year, so that's going to be 4.5. 4.5. So that's the second answer, that's the first answer. All right, that's the first two. And again, from what I looked at, what you guys submitted, a lot of you got that right. Okay, now number 3. Growth of a certain strain of bacteria is modeled by that equation. Now this was the most missed question when I looked at the sheet, and we're going to talk about why. A to the 2.7 0.584T. Okay, where G is the bacteria, A is the initial, T is out. Okay, in approximately how many hours will 4 bacteria increase to 2,500? Well, what's the original amount of bacteria? Well, it's 4. 2.7, 0.584T, and we want it to equal 2,500. All right, so we're going to do what we did in the other ones. We're going to divide by 4. Okay, which I can tell from your answers, a lot of you did. So I'm getting 625. So this is 625 equals 0.27, 0.5. Actually, I'm going to make that look neater for you guys. 0.584T. Okay, so now I'm going to rewrite it using a log. I'm going to write log, the base is 0.27, 625 goes here, equals 0.584T. So now I'm going to type this in my calculator. So math, go up to log, 0.27, 625. I am getting, it looks like, let's see here, negative 0.44, oh my God, I'm writing that one. Okay, negative 4.9168. Now I'm not going to round until the very end, equals 0.584T. Just going to double check what I've got written here. 2.7, oh, that's why. I'm a little off when I typed it in my calculator. It's 2.7, not 27. 27. I'm going to make a little fix. Now, one of the reasons why I knew the answer was off, and this is how you guys can check yourself, I got a negative number. And you can't have negative time. So that's how I knew something was amok, and I went back and looked. So now I'm just going to re-enter it. Math, log 2.7, 625, and that's better. That gives me 6.48149. So I'm not going to round it yet. I don't round it to the very end. Okay? Now, to get t alone, I'm going to divide by 0.584. So I'm going to divide it by 0.584. And I'm getting 11.09. Okay, now let's go back and look at the question. In approximately how many hours will 4 bacteria first increase to 2,500? Round your answer to the nearest hour. Okay, so most of you had 11, which is actually correct considering this is how it's rounding. The computer system had 12 down because they thought that if you left it at 11, you wouldn't quite reach 4, right? But I would accept the 11 on that one because the wording's bad. So if you, even though I marked you guys all wrong, I would accept that as correct. Okay, next one down. The growth of bacteria in a dish is modeled by this equation, for which value of t is f of t equals 32. So that means they want us to put 32 right there. Right? And then we can just log this. Log 2, 32 equals t over 3. All right, so I'm going to do math, scroll up to log 2, 32, and then 5. All right, now let's take a look at this. See how this is a fraction? Make this look like a fraction. Cross multiply. I get t equals 15. That's choice C. Okay. So again, most of you did a nice job on that stuff. All right, let's try the next couple. Number 5. Kathy deposits $25 into an investment account with an initial investment account with an annual rate of 5%. And here's the formula. All right. If t is the number of years, if she makes no other deposits or withdrawals, how much will she have at the end of 15 years? All right, so look at our formula. Okay. P, right, whatever's in front of the parentheses is the original amount. So that's $25. So 25. 1 plus R is the percent, but change it to a decimal. So it's 0.05, right? 15 years. So that's the time. And this time it's going to give us the amount. So this one actually is pretty easy. Just type it in, 25. 1 plus 0.05 raised to the 15. And it looks like it's $51.97. So here we go. Choice C. All right. Is the equation right here a model of growth or decay? And what is the percent it's changing by? All right, now I'm going to write it a little bigger. It's 21,000. 1 minus, and that's the key right there. The fact that it's a minus means it's a decay. All right, so it's definitely not growth. So I can get rid of anything that says growth. Now, right, what is the rate of change per time period? All right, well, how much is this? What would this rate be? 0.12 would be what as a percent? 12%. So that should have been choice C. Number 7. The current population of a town is 10,000. If the population increases by 20%, what would it be after t years? All right, you have to create your own equation. So what's the original amount or current amount? That's always what you start with. So it's 10,000. Okay? Then parentheses and a 1. Now, is it increasing or is it decreasing? Increasing. So I'm going to put a plus. 20%. So you're going to write down 0.20 in t years. And that's going to give us the population. So which of these choices would be the same as this? And that's also choice C, right? Because when you add these together, you get 1.2. And finally, number 8. The number of bacteria present in a petri dish can be modeled by the function, this guy's going to be n equals 50 e to the 3t, where n is the number of bacteria present in the petri dish after t hours. Using a model to the nearest hundredth, the number of hours it will take to reach this guy's 30,700 equals 50 e to the 3t. All right, so even though it's e, we're still going to solve it the same way. What should we be dividing by first? I'm hoping you're thinking 50. You're always going to get rid of the number in front of the parenthesis, or in this case, the e. So I take my calculator, do 30,700 divided by 50. I get 614. 614 equals e to the 3t. Now I'm going to rewrite this as a log. Now remember, e gets its own special log, which is natural log. So natural log of e, which you don't have to write there, 614 equals 3t. So the natural log button is over here next to the 4. So natural log, you do not have to put the e. It's already built into the calculator. I'm going to type in 614. And I'm getting that guy. So it's 6.419994928 equals 3t. And then I'm going to take that and divide by 3. And this time I want to round to the nearest hundredth, so 2 decimal point places, so 2.14. All right. Now remember, when you're entering into the computer program, you only have to put the number. Don't put x equals or it marks you wrong. So that should have been the answer to number 8. So most of you did do a great job on that homework assignment. All right. Now, what I want to do is I want to practice 2 other questions with you guys. And to do that, you need to go look at the paper I posted up there. It's a worksheet that says exponential word problems. So if you haven't looked at that yet, either go print it out, or you're going to copy the questions down on a piece of paper and do it. We're actually going to do numbers 3 and 4 together, and possibly 5. Okay, so print that out. Right, so you can pause me, go do that, or write the questions down. All right, so what I'm hoping, everybody, is that you either printed them out or wrote it down, and let's jump in and take a look at them. So I'm going to do number 3. I'm going to do the second page. It says you bought a computer for $2,200, and it depreciates by 15%, and there's a new piece we're going to throw in, every 3 years. So what I'm going to do now, I'm going to stop. I'm going to go back to my formula sheet. I'm actually going to add another piece to the puzzle. I'm going to take the T and put it over K. K represents the word every. Put in quotes. You see the word every, it means the time is going to be chopped up by that word. So let me show you how that's going to work here. So, what is the original amount of the computer? 2,200. So I'm going to put that down, and the original amount always goes in front of the parenthesis. Then I'm going to write the number 1. Now, is this computer increasing or decreasing? What does depreciates mean? Depreciates means it's going to go down. So it's 2,200, 1 minus 15%, right? How much will it be worth in 5 years? That's time. But see this word every? It's every 3 means you're dividing the 5 by that number. And that's the only change. And that's what we're going to put into our calculators now. So I'm going to do 2,200, 1 minus 0.15, raised to the fraction button this time because it used the word every, 5 over 3. And it's money, right? Because it's money, so we're going to go near cent. 1677.98. Right. Okay, let's look at number 4 now. A radioactive isotope has a half-life of 8 months. if you currently have 500, how much would you have in 2 years? All right. Now, what's the original amount? 500. So we start with that. Now, half-life. 2 different ways of doing it. What percent would be half of something? 50%. Right? So that means we're taking away 50% of it, right? And the half-life means it's happening every 8 months. So what you're going to do is take the 2 years and divide it by, well, this is in months. We actually have to change our years into months. How many months, guys, are in 2 years? 24 over 8. And that's what we're going to put into our calculators. So I'm going to do 500, 1 minus 0.50, raised to the 24 over 8. And again, I did 24 because the every was in months. So everything has to be in months. Whoops. There you go. That's 62.5 grams. Now, something else to keep in mind, right? If I were to subtract these, right, 1 minus 0.50 is 0.50, right? That's what I end up doing. You're actually legally allowed, mathematically legal, just to throw the half in there. And it means exactly the same thing. So anytime you see half-life, especially in chemistry, that's what you can do there. And we're going to use the same idea to do this gremlin equation here. Okay. Once gremlins come in contact with water, they triple in number every 2 minutes. Should 5 gremlins come in contact with water, how many will you have after an hour? All right. How many gremlins are we starting with? 5. Okay. Now, see how this was half-life? And I said you could throw in a half? Well, if you're going to be tripling something, what you're allowed to do is throw in a 3. So if I say you're doubling something, you could put a 2. If you're quadrupling something, you could put in a 4. So it's a little shortcut. All right. How many would you have after an hour? Now, look at your every. Your every is in minutes. Right? So that means it's going to be over 2, because that's your every. How many minutes are in an hour? That would be 60 minutes. So we're going to put a 60 there. And I'm going to put that in my calculator. All right, let's see how many gremlins we have. The 3 raised to the 60 over 2 would be 30, right? Or you just put 60 over 2. Whoa, so let's talk about what that means. E, right? That's scientific notation. That means we'd have 1.2945566. The E means times 10 to the 15. That's an awful lot of gremlins. That means basically they're taking over the place. Okay. And last one. How long to the nearest tenth of a minute will it take to have 50 gremlins? All right. This time we don't know the time. So we have 5. It triples. We don't know the time, but we know it's going to happen every 2 minutes. And I want to have 50. All right. The first thing we're going to do is divide by 5. So that's 3 to the t over 2 equals, that'll be 10. And then we're going to log this. Now I'm going to do it the other log because we did a few the other way. I'm going to log this. Log 3 t over 2 equals log 10. The t over 2 falls in front. Right. Trying to get t alone, so I'm going to divide by log 3. So I get t over 2 equals, so I'm going to put that in the calculator. Log 10. Log 10 divided by log 3. I'm getting 2.095903. Remember, I'm not going to round to the very end. Now I have this fraction equal to this, so I'm going to put this over 1 and cross multiply. T equals, so I'm going to times that by 2. And I want it to the nearest tenth of a minute. This would be 4.2 minutes. All right. So now what I want you guys to do for homework tonight for me is the first page of this worksheet. What I'd like you to do in this worksheet, number 1, A through D, and number 2. And you're going to enter those into a Google form sheet.